Now, what about using the binomial theorem to expand the same binomial expression raised to the fourth power? Well, the binomial theorem specifically for this binomial expression is a summation from lower limit of summation k equals 0 all the way to the upper limit of summation, which is the exponential power 4, of the product of the combination 4 factorial divided by k factorial multiplying 4 minus k factorial 2 raised to the 4 minus k exponent and negative x raised to the k exponent. So since this is a summation, we are going to be adding a few things, but what are those few things? Well, those few things are going to be the product, this product, starting with the lower limit of summation equal to 0. We take 0, replace all of the k with 0, move on to the next k value, take this same products, but now replace all of the k with 1, and then with 2, 3, all the way up to 4. And then eventually we have to add all of those products together. And eventually you see that the answer for expanding this binomial expression using the binomial theorem is going to be the same as this one. But this is just going to be a little longer, or a lot longer I should say, but it's doable. So let's start with k equal to 0. So if k equal to 0, we're going to have 4 factorial divided by 0 factorial multiplied by 4 minus 0 factorial, multiplying 2 raised to the 4 minus 0 times negative x raised to the 0. 0 factorial is going to be positive 1. 4 minus 0 is going to be 4. 4 factorial divided by 4 factorial is going to be just 1 and 1 here because they cancel each other out. Anything raised to the 0 exponential power is going to be positive 1. So this is positive 1. 4 minus 0 is 4. 2 raised to the 4th is going to be 16. So we got 1 times 16 times 1. This is just going to be equal to 16. Now if k equals to 1, we still have the same product. 4 factorial divided by, but now k is going to be equal to, k is going to give us 1 factorial multiplied by 4 minus 1 factorial times 2 raised to the 4 minus 1 times negative x raised to the first. Well, let's expand it out a little more. I'm going to rewrite this into 4 times 3 factorial. And I'm going to stop at 3 factorial here because I'm going to be canceling it out since I'm simplifying. And then 1 factorial is going to be positive 1. 4 minus 1 is going to be 3, so this is 3 factorial. But hey, they cancel each other out. And then for this one, 4 minus 1 is 3. 2 raised to the 3 is going to be positive 8. Negative x raised to any odd exponential power is going to be its negative version. So it's going to be negative x, like that. So we got 4 times a times negative x is going to be negative 32x, like that. Now if k equals 2, we got 4 factorial over 2 factorial times 4 minus 2 factorial multiplied by the first term, which is 2 raised to the 4 minus 2 times negative x raised to the second. Well, let's simplify a little more. 4 factorial, I'm going to write it 4 times 3 times 2 times 1. 2 factorial is the same as 2 times 1. 4 minus 2 is 2. 2 factorial is the same as 2 times 1. Well, let's see. We got 2 times 1, which is 2. 2 times 1, which is 2. 2 times 2 is 4. So this denominator is 4. 4 over 4, well, guess what? They cancel each other out. So we're left with just 3 times 2 times 1. 4 minus 2 is 2. 2 raised to the 2 is going to be positive 4. Negative x raised to any even exponential power is going to be its positive form. So this is going to be positive x squared. 3 times 2 times 1 is going to be 6. 6 times 4, 24. Times x squared is going to be 24x squared. When k equals to 3, we got 4 factorial over 3 factorial multiplied by 4 minus 3 factorial. And this is pretty straightforward, as you can see. let's see, this 4 factorial is going to be 4 times 3 factorial over 3 factorial multiplying by 4 minus 3 is 1. 1 factorial is just going to be positive 1. 3 factorial cancel out. 4 minus 3 is 1. 2 raised to the first is just going to be itself. 2 itself. Negative x raised to any odd power is going to be its negative form. So negative x, third. Yeah, negative x raised to the third. 4 over 1 is 4. 4 times 2 is 8. 8 times negative x to the third is going to be negative 8x cubed. When k equals to 4, which is the upper limit of summation, we got 4 factorial over 4 factorial times 4 minus 4 factorial times the first sum 2 raised to the 4 minus 4 times negative x raised to the fourth. Well, 4 factorial right here cancel out. 4 minus 4 is 0. 0 factorial is going to be positive 1. So this whole thing is positive 1. 4 minus 4 is 0. Anything raised to the 0 is going to be positive 1. Negative x raised to any even exponential power is going to be its positive form. So this is positive x to the fourth. So hey, 1 times x to the fourth is going to be x to the fourth. So adding everything together, 2 minus x raised to the fourth is going to be equal to the sum of, let's see, starting with the highest exponential power of the x first, x to the fourth, plus negative 8 x to the third, plus 24x squared, plus negative 32x, plus negative 32x, and then plus 16. But hey, guess what? Our answer, using the binomial theorem, is the same as the one above.